Honors Pre-Calculus Final Exam, question number 55. This is question number 58 on the Final Exam Review for 2013. Number 58 on the exam review says, find V for the tip of the hour hand of a clock if the hand is 11 centimeters long. Now they're asking us to assume something that we know what this V stands for, and they really should say find the linear velocity, because the V could mean something else. But I think they mean us to understand here that the V is the linear velocity. So again we have something that's turning around, a clock hand, and we need to know something about how fast it's moving. So that brings us back to our formulas that we talked about for number 56. And here's all our formulas that we have about things moving around. So let's look at what the information that is given to us is. So on this problem, we have V is what we're trying to find. So I always try to identify what is the question. What's the variable that we're trying to find? And that's our linear velocity. Then it says the hand is 11 centimeters long. The hand, let's see, was my hand 11 centimeters long? I don't know, but they're talking about the hand of a clock. So maybe I need to think about the fact that a clock is round and the minute hand is on the clock and that minute hand is going around. And so it says that the hand is 11 centimeters long, means this is 11 centimeters. So what I'm trying to get a handle on is, what is this 11 centimeters? Which variable? Is it arc length? Is it radius? Is it angle, area? What is it? So one thing I know is that since it's measured in centimeters, it has to be arc length or radius, because those are the only things that are measured in distance. And since the hand of the clock doesn't wrap around this way, it's more like a radius of a clock. So the 11 centimeters is a radius of the motion of that hand. So that's the R. That's R equals 11 centimeters. Now that's all they've told us, except for the fact that it's an hour hand. So let's just write that off here. It's not really a variable. It's an hour hand. We'll have to think about what that means. Now that's all the information they gave us. Find V, so we know that. Radius, they gave us that. And it's an hour hand. Now we need to try to match up this information with some of our formulas. Well, we don't have a whole lot to go on here, but we do have V and R, and there's only one formula that has V and R in it. It's V equals R omega. So let's start by thinking about that. V equals R omega. And let's see, V is what I'm trying to find. R is 11 centimeters. But here's my problem, is that I don't know what omega is. Now if I knew what omega was, I could solve for V. But it's clear that that's my problem. I need to find out what omega is. So now is where I'm going to use the fact that it is the hour hand of a clock. And oh, I know I can find the omega by looking at, I have a formula for omega. It says omega equals theta over t. So if I could use that omega equals theta over t, and the fact that it's the hour hand of a clock, maybe I could get the omega. So what I want to do for the hour hand of a clock is say, well, what do I know about the hour hand of a clock? What does it do? What is the theta and what is the t? If I knew theta and t, I could get omega, and I could put my omega here and solve for V. So let's look at these variables. So what do I know that an hour hand does? Well, the hour hand of a clock, I'll start it from midnight. It goes around once. And so when it goes around once, it makes one revolution. Let's write it like that. It makes one revolution. And how long does it take to do that? How long does it take the hour hand to go around? If you think about that, a lot of people answer it wrong. A lot of people think, how long does the hour hand take to go around? Well, an hour. No, it doesn't take an hour. Oh, okay, so it's the hour hand to go all the way around. Is it 24 hours because that's a day? No, how long does it take the hour hand to go around? If this is 12, 1, 2, 3, so it has to go around 12 hours to get to here. So the time is 12 hours. That's the time. All right, now my one revolution, we're going to put that, we want our omega, we'd like to think about what our omega units should be. I think they certainly should be radians per something. Let's look at what they ask us, give us in the question. Now they say find V, but they don't say in what unit to find it. We could find it in centimeters per hour, or centimeters per second, or miles per hour if we wanted, because it doesn't say what units to find it in. Let's find it in centimeters per hour, because that will be the easiest thing to do since it's an hour hand and our time is in hours. But then, just in case on the exam they ask you to give it in, let's say, meters per second, we'll convert it to meters per second. But let's start with centimeters per hour because that will be the easiest thing to do and arguably is the most logical way to express a very slow speed like that because of course the hour hand does not move very fast. So let's leave our time in hours. Let's make our theta be 1 revolution, which is 2 pi radians. Now when we use this formula, everything must be in radians. Every angle must be in radians. We can't use these formulas in degrees or in revolutions. So we do have to convert the theta to radians. All right, so now we can get a handle on our omega. Since omega is equal to theta over t, that means it must be equal to, our theta is 2 pi radians, our time is 12 hours, so we can call that pi over 6 radians per hour. And maybe we could make a decimal out of that if we wanted, but why not just leave it pi over 6? The problem doesn't ask for an exact value, but let's leave it pi over 6 and round at the end, if anything. So now that we've got what the omega is, we can plug that back into here, and we can say that V is equal to 11 centimeters times pi over 6 radians per hour. So now we just have to do 11 times pi over 6. So we could call it 11 pi over 6 and be done there. We could say it's 11 pi over 6 centimeters per hour. And notice that a funny thing happens when we combine the units. Centimeters times radians per hour gives you centimeters per hour. Here's the centimeters on the top, here's the hour on the bottom. What happened to the radians? When the radians combine with another unit, they vanish because radians are not really a unit, they're really a ratio. So that's a long story, but you want to know that when you combine radians with other units, they tend to vanish. All right, so we could leave an answer here, and we could say that is a correct answer to that question. But I have a hard time getting a handle on what is 11 pi over 6 centimeters per hour. I mean, how fast is that compared to, say, a car? I have no idea. So let's get at least a decimal for it, and we'll do 11 pi divided by 6. And we'll get our decimal, that's 5.795. Oh, let's just call it 5.76. So we can call it 5.76 centimeters per hour. And that's also probably an adequate answer. Now what I want to do is go a little bit beyond the question because the question did not specify the units of the answer. But it's quite possible that the exam would ask you to give the answer in some other unit, let's say meters per second. So in that case we would have to make a conversion. So let's say we wanted to convert our result to meters per second. Then what we would do is take our 5.76 centimeters per hour, and we want to write that centimeters per hour, we want to write it as a fraction like this. That'll help us set up our canceling fractions. So our canceling fractions, and we can do them in any order. Let's start with the centimeters because that's easy. Now what I want to think is, I want to change the centimeters to meters because I want meters per second. So what I'm going to do is cancel the centimeters out. So I want to put centimeters on the bottom, that way it will cancel with the centimeters on the top. And I'll put meters on the top. So the first thing I decide is what goes where. I want the centimeters to cancel, so I put them opposite to each other. Now I think, what do I know about meters and centimeters? Well, I know that 1 meter equals 100 centimeters. So since these two are equal, I'm really just multiplying by 1. Now I'm going to set up another fraction because I want seconds. So that other fraction is going to help me change the hours to seconds. Well, I want the hours to go away, so that means I want the hours on top. And I want seconds to show up, so I'm going to put seconds on the bottom. But the important thing was the hours go on top so that they will cancel. Now I think again, what do I know about hours and seconds? Well, I know that 1 hour equals 3,600 seconds. Now I've set up two fractions so that the hours will cancel with the hours. The centimeters will cancel with the centimeters, and what I'll be left with is meters per second, which is what I want, meters per second. Now that I have my fractions set up, I just have to know that I multiply the things on the top and divide the things on the bottom. So if I had a number up here, I would multiply it. I have only ones at the top, so that means I have to divide everything. So we're going to go 5.76 divided by 100 divided by 3,600, and that equals 1.6 e negative 5. So that, hopefully you know what this means. This is scientific notation. It's 1.6 times 10 to the negative 5th power. So that is 1.6 times 10 to the negative 5th power. meters per second. Now, does it surprise us that it's in scientific notation and it's a negative exponent? It should not surprise us because this is the hour hand of a clock. It moves very slowly. So if I use meters per second, which is a type of speed that I might use to measure the speed of a bicycle or a car, something that's moving rather fast, I'm going to expect that to be a very, very small number. In fact, if I were to put that in standard notation, which I probably wouldn't want to do, but it would be 0.000016 meters per second. So my calculator went ahead and expressed that in scientific notation. But so this is in meters per second, this is in meters per second. The problem didn't ask for it, but it's a good thing to review. And that is how we're going to get our answer. And remember, by the way, these two are acceptable answers to number 58. That's number 58, and you do 59 the same way.